Plugging a ground fault circuit interrupter, or GFCI, relocatable power tap into a regular outlet does not transform that regular outlet into a GFCI protected outlet. The GFCI functionality inherent in the power tap is limited to safeguarding the outlets located directly on the power tap itself. Consequently, the original wall outlet to which the power tap is connected retains its status as a non-GFCI protected outlet and does not benefit from the GFCI protection provided by the power tap. According to the National Electrical Code, abbreviated as NEC, it is generally not considered acceptable to rely solely on a GFCI power tap to meet the GFCI protection requirements for outlets in kitchens. The NEC mandates GFCI protection for all outlets installed in kitchens. This requirement encompasses both permanently installed wall outlets and relocatable outlets found on power taps. To ensure complete GFCI protection for all outlets within a kitchen environment, you should consider the following options. Firstly, replace the existing standard wall outlet with a dedicated GFCI outlet. This will provide GFCI protection not only for the wall outlet itself, but also for any devices subsequently plugged into it. Secondly, employ a GFCI power strip. A GFCI power strip offers GFCI protection for all devices connected to it, irrespective of the type of wall outlet into which it is plugged. It is crucial to select a GFCI power tap specifically designed and rated for kitchen use. Kitchen-grade power taps are engineered to be more robust and resilient, enabling them to withstand the demanding conditions typically encountered in a kitchen environment. These conditions may include exposure to water, cooking oils, and other potential hazards. Understanding ground fault circuit interrupters. A ground fault circuit interrupter, or GFCI, is a vital safety device designed to protect individuals from electrical shock. It works by monitoring the balance of electrical current flowing through a circuit. In a properly functioning circuit, the current flowing through the hot wire should precisely equal the current returning through the neutral wire. However, if a ground fault occurs, such as when current leaks to ground through a person touching a live wire or a faulty appliance, the current balance is disrupted. The GFCI swiftly detects this imbalance and immediately cuts off the power supply to the circuit, typically within a fraction of a second. This rapid response helps prevent severe electrical shock or electrocution. GFCIs are commonly installed in areas where there is a high risk of contact with water, such as bathrooms, kitchens, and outdoor locations. The National Electrical Code mandates the use of GFCIs in these areas to enhance electrical safety. Key differences between GFCI outlets and GFCI circuit breakers. GFCI protection can be implemented using two primary methods: GFCI outlets and GFCI circuit breakers. While both serve the same fundamental purpose of preventing electrical shock, they differ in their location and scope of protection. GFCI outlets: these devices are installed directly in place of standard electrical outlets. They provide localized GFCI protection specifically for the outlet itself and any devices plugged into that outlet. GFCI outlets are easily identifiable by the presence of test and reset buttons on their face. They are commonly used in areas where GFCI protection is required at specific locations, such as bathrooms and kitchens. GFCI circuit breakers: these devices are installed in the electrical panel and provide GFCI protection for the entire circuit. When a ground fault is detected anywhere on the circuit, the GFCI circuit breaker trips, cutting off power to all outlets and devices connected to that circuit. GFCI circuit breakers offer broader protection compared to GFCI outlets, as they safeguard the entire circuit rather than just a single location. They are often used for circuits that serve multiple outlets in areas where GFCI protection is needed throughout, such as outdoor circuits or unfinished basements. National Electrical Code GFCI requirements. The National Electrical Code, commonly referred to as the NEC, establishes comprehensive standards for electrical installations to ensure safety and prevent electrical hazards. The NEC mandates the use of ground fault circuit interrupters, or GFCIs, in specific locations and applications where there is an increased risk of electrical shock. Some key NEC GFCI requirements include bathrooms all 125 volt, 15 and 20 amp receptacles installed in bathrooms must be GFCI protected. This requirement applies to both residential and commercial buildings. Kitchens, all 125 volt, 15 and 20 amp receptacles serving kitchen countertops must be GFCI protected. This includes receptacles located within 6 feet of a sink. Garages, all 125 volt, 15 and 20 amp receptacles installed in garages must be GFCI protected. This requirement applies to both attached and detached garages. Outdoors, all 125 volt, 15 and 20 amp receptacles installed outdoors must be GFCI protected. This includes receptacles located on decks, patios, and in other outdoor areas. Unfinished basements, all 125 volt, 15 and 20 amp receptacles installed in unfinished basements must be GFCI protected. This requirement helps to prevent electrical shock in damp or humid environments. Crawl spaces, all 125 volt, 15 and 20 amp receptacles installed in crawl spaces must be GFCI protected. This requirement is similar to that for unfinished basements. Boathouses, all 125 volt, 15 and 20 amp receptacles installed in boathouses must be GFCI protected. This requirement is specific to structures located near water. Understanding GFCI power strips. A GFCI power strip is a specialized type of power strip that incorporates ground fault circuit interrupter, or GFCI protection. It is designed to provide an additional layer of safety by detecting ground faults and quickly interrupting the power supply to prevent electrical shock. GFCI power strips are particularly useful in areas where GFCI protection is required, but a standard GFCI outlet is not readily available. They can be used in kitchens, bathrooms, garages, and other locations where there is a risk of contact with water or moisture. How GFCI power strips work. GFCI power strips operate on the same principles as GFCI outlets and circuit breakers. They continuously monitor the balance of electrical current flowing through the hot and neutral wires. If a ground fault occurs, indicating that current is leaking to ground through a person or a faulty appliance, the GFCI power strip instantly detects the imbalance and trips, cutting off the power supply to all devices plugged into the strip. This rapid response helps prevent electrical shock or electrocution. Advantages of using GFCI power strips. GFCI power strips offer several advantages over standard power strips. Firstly, enhanced safety. They provide GFCI protection, which can prevent electrical shock in wet or damp environments. Secondly, portability. They can be easily moved from one location to another, making them ideal for temporary setups or areas where GFCI outlets are not available. Thirdly, convenience. They offer multiple outlets for plugging in various devices while providing GFCI protection. Fourthly, cost-effectiveness. They can be a more affordable option compared to installing GFCI outlets in certain situations. When to use a GFCI power strip. GFCI power strips are particularly useful in the following situations. Firstly, temporary setups when you need GFCI protection in a temporary location such as a construction site or outdoor event. Secondly, older homes that may not have GFCI outlets installed in areas where they are now required by code, such as kitchens and bathrooms. Thirdly, limited outlet availability when you need to plug in multiple devices in an area with limited outlets, and you want to ensure GFCI protection for all of them. Fourthly, travel. When traveling to areas with different electrical standards, a GFCI power strip can provide a safe way to plug in your devices. Choosing the right GFCI power strip. When selecting a GFCI power strip, consider the following factors. Firstly, amperage rating. Ensure that the power strip has an amperage rating that is sufficient for the devices you plan to plug into it. Secondly, number of outlets. Choose a power strip with the appropriate number of outlets to accommodate your needs. Thirdly, cord length. Select a power strip with a cord length that is suitable for the distance between the outlet and the devices you want to plug in. Fourthly, UL listing. Look for power strip that is UL listed, indicating that it has been tested and certified for safety. Fifthly, durability. Choose a power strip that is made from durable materials and is designed to withstand the rigors of everyday use. Testing and maintaining GFCI power strips. It is essential to test GFCI power strips regularly to ensure that they are functioning correctly. To test a GFCI power strip, simply press the test button on the device. The power strip should trip, cutting off the power supply to the outlets. If the power strip does not trip, it may be faulty and should be replaced. It is also important to keep GFCI power strips clean and dry. Avoid exposing them to water or moisture, as this can damage the internal components and compromise their safety. Important safety tips. Always follow these safety tips when using GFCI power strips. Firstly, do not overload the power strip. Avoid plugging in too many devices that exceed the power strip's amperage rating. Secondly, do not use damaged power strips. Never use a power strip that has a damaged cord, plug, or housing. Thirdly, do not use in wet locations. While GFCI power strips are designed to provide protection in wet locations, it is still important to avoid exposing them to excessive moisture. Fourthly, test regularly. Test the power strip regularly to ensure that it is functioning correctly. Fifthly, replace when necessary. If the power strip fails a test or shows signs of damage, replace it immediately. Understanding the National Electrical Code. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and maintained by the National Fire Protection Association, or NFPA, and is updated every 3 years to reflect the latest advancements in electrical safety. The NEC is not a law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Its primary purpose is to ensure the safety of people and property from electrical hazards. Key areas covered by the NEC. The NEC covers a wide range of topics related to electrical installations, including firstly, wiring methods. It specifies the types of wiring and cabling that are permitted for different applications. Secondly, overcurrent protection. It establishes requirements for circuit breakers and fuses to protect against overloads and short circuits. Thirdly, grounding and bonding. It outlines the methods for grounding and bonding electrical systems to minimize the risk of electrical shock. Fourthly, equipment installation. It provides guidelines for the installation of electrical equipment, such as lighting fixtures, appliances, and motors. Fifthly, hazardous locations. It addresses the requirements for electrical installations in areas where flammable or explosive materials are present. How the NEC is organized. The NEC is organized into chapters, articles, and sections. The chapters cover broad topics such as general requirements, wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and special conditions. The articles provide more specific requirements within each chapter. The sections offer detailed instructions and specifications for specific aspects of electrical installations. Using the NEC effectively. To use the NEC effectively, it is important to understand its organization and how to navigate its various sections. It is also essential to have a solid understanding of electrical principles and practices. When working on electrical installations, always refer to the latest edition of the NEC and consult with a qualified electrician if you have any questions or concerns. Common NEC violations. Some common NEC violations include firstly, improper wiring methods, using the wrong type of wiring or not installing wiring correctly. Secondly, overfusing, using a fuse with a higher amperage rating than the circuit is designed for. Thirdly, lack of grounding, not grounding electrical systems properly. Fourthly, improper use of extension cords, using extension cords as a permanent wiring solution. Fifthly, blocked access to electrical panels, obstructing access to electrical panels, which can hinder maintenance and repairs. Importance of electrical safety. Electrical safety is paramount to protect yourself and others from electrical hazards. Electricity can be dangerous if not handled properly, and electrical accidents can result in serious injuries or even death. By following electrical safety guidelines and adhering to the NEC, you can significantly reduce the risk of electrical accidents and ensure a safe electrical environment. Basic electrical safety tips. Here are some basic electrical safety tips. Firstly, never work on live electrical circuits. Always turn off the power at the circuit breaker before working on any electrical wiring or equipment. Secondly, use the right tools. Use insulated tools that are designed for working with electricity. Thirdly, inspect electrical cords and equipment regularly. Check for any signs of damage, such as frayed cords or cracked housings. Fourthly, avoid overloading circuits. Do not plug in too many devices into a single circuit, as this can cause overheating and potentially a fire. Fifthly, keep electrical equipment away from water. Water is a conductor of electricity, so keep electrical equipment away from water sources. Sixthly, use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of contact with water, such as bathrooms, kitchens, and outdoor locations. Seventhly, call a qualified electrician for any electrical work that you are not comfortable doing yourself. Always hire a qualified electrician to perform the work. Understanding amperage. Amperage, often measured in amps, represents the flow rate of electrical current within a circuit. It's a fundamental concept in electrical science, analogous to the rate at which water flows through a pipe. The higher the amperage, the greater the volume of electrical charge moving through the circuit per unit of time. This flow of current is what powers electrical devices and equipment. However, it's crucial to manage amperage effectively to prevent overloads and potential hazards. Understanding voltage. Voltage, typically measured in volts, quantifies the electrical potential difference between 2 points in a circuit. It signifies the driving force that compels electrical current, measured in amperes, to flow through the circuit. Visualize it as the pressure in a water pipe propelling water flow. Higher voltage implies a greater electrical pressure, facilitating a more substantial current flow, provided there's a pathway for it. Different appliances and equipment are designed to operate at specific voltage levels, necessitating compatibility between the voltage source and the device for safe and efficient functioning. A mismatch in voltage can lead to malfunction or even damage. Understanding wattage. Wattage, gauged in watts, serves as a measurement of electrical power, signifying the rate at which electrical energy is utilized or dissipated within the circuit. It's computed by multiplying voltage in volts by current in amperes. Wattage unveils the amount of work electrical energy can perform per unit of time. Appliances and devices are typically labeled with their wattage, indicating the power they consume during operation. Knowledge of wattage is pivotal for calculating energy consumption and sizing electrical circuits adequately. Staying safe with electricity. Electricity is a silent force that powers our modern world, but it also demands respect and caution. Whether you're a seasoned electrician or a homeowner tackling a simple repair, understanding and adhering to electrical safety principles is paramount. Always treat electricity with care, never underestimate its potential hazards, and prioritize safety in every electrical endeavor. From recognizing potential risks to following established safety protocols, safeguarding yourself and others from electrical harm is a responsibility we all share. In conclusion, always prioritize safety and consult with a qualified electrician when dealing with electrical work.